Good morning, everybody. Coming to hepatic iron quantification, today we'll be discussing about MR imaging. Super paramagnetic. There are substances. Iron is a super paramagnetic substance. Super paramagnetic effect of ferritin, hemosiderin. It creates a local susceptibility, induces distortion to the local magnetic field that results in faster decay of transverse magnetation. Transverse magnetation, T2 star, everything you have to go and see my previous videos. If you understand that concept only, then you'll understand this. So this causes distortion of local magnetic field leading to faster decay of the transverse magnetation. Coming to imaging, we have gradient recalled echo sequences which is mainly used in T2 star for signaling. Here what we do, gradient recalled echo sequences at multiple echo times we are taking. Like this is like 1 millisecond, 2 millisecond, 3, 4, up to 7.4 milliseconds. Multiple will take. What happens in hepatic iron deposition? Liver signal drops very fast. This is 1 millisecond, this is 7.4 millisecond. Depending upon whether there is a mild iron deposition or severe iron deposition, there will be signal drop. What we do here is this signal drop is estimated, that is quantification is done by T2 star. Why not T2? T2 we need breath hold for T2. So it will be very difficult for multiple echo times, right? Here in single breath hold technique we can do this sequences. So this signal drop is estimated. So in T2 breath hold is required. In T2 star, in single breath hold we can acquire this sequence. That is mainly gradient recalled echo sequence we will do. So T2 star is taken. So normally what we do is we do relaxometry method. What is relaxometry? We measurement of relaxation times for MR. We take the MR images and see the relaxation times and we measure it. Measurement of relaxation time from MR images. This is relaxometry. We take a graph where there is a time echo time, that is which is milliseconds. The T2 star is measured in milliseconds and signal intensity. See what happens normally in iron overload. As iron overload increases, the decay occurs very fast. For example, in severe iron deficiency, after 1 milliseconds at 1.5 to 2 milliseconds only, the liver parenchyma saturates. For example, if mild iron overload at 10 or 15 milliseconds, the decay occurs. See here. It depending upon the iron load. If there is very severe at here this is 0, 5, 10, 15, 20 milliseconds, right? Time to echo. If the iron overload is very severe, at 1.5 to 2 milliseconds only, the signal drop will be there. Signal drop. If it is little mild, at little higher levels, 10 to 15 milliseconds, will have signal drop. Then R2 star. What is R2 star? The rate at which the signal decay occurs. That is the R2 star. It is measured in hertz. Remember T2 star it measured in milliseconds. R2 star it measured in hertz. R2 star is the rate at which the signal decay occurs. One more is the chemical shift imaging. In chemical shift imaging, this is time to echo, right? This is 4.2 milliseconds, this is 2.2 milliseconds. We have in phase or out phase. First we get out phase, right, at 2.1 milliseconds, then we get in phase at 4.2 milliseconds. What happens in excessive iron deposition is paradoxical shift of the signal drop. That is in phase there is severe signal drop compared to the out phase. This sentence you remember, man. If you write this sentence, it's enough in exam. In exam when they ask what you will do means T2 star you write, man. Super paramagnetic effect, it causes distortion of the local magnetic field, faster decay. You write about T2 star. T2 star and it's T2 star GRE you mentioned, you underline them. Obviously you'll get out mask and you draw this graph. Write about R2 star. R2 star is rate at which the signal decay occurs. Write about what happens in severe and what happens in mild. And then write about chemical shift imaging. Normally what happens in chemical shift imaging, what happens. Thank you.